The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
So, I want to go a little bit about what the class is, what we are going to do. So, I just put one slide about requirements and outcomes. So what are the requirements? We require you to be a good programmer with a lot of programming experience. Because as I said, we are going down to very bare metal. And there won't be any niceties of just writing Java code. So you're going to run into a lot of these kind of issues. Fluent in C is, I wouldn't call it a 100% requirement. But it would really help if you're fluent in C. If not, you'll have to probably spend a lot of time trying to understand C, C++. And in this class, that means just start doing it today. Just get a C book and then try to understand. So if you have done a lot of Java, it might be easy transition, but get to the transition fast. Don't wait. What are we expecting at the end? We expect at the end for you to know.
I have to go.
Good.
Thank you very much. In this event.
Okay. Yeah. So what do you expect? We expect at the end you'll probably understand a lot of fundamentals and concepts about parallel programming, both hardware and software. Because the nice thing about, the bad thing about Cell is a lot of hardware concepts are also exposed. There's no nice abstraction layers in there. You'll understand a lot of issues about parallel performance. I mean, we started here. It's not you write a program, compile. It's not just order n you're looking for. You're looking for all these constants. All these things matter basically. You should be able to synthesize a fairly complex parallel program by this end, because that's what the project's going to be. And you'll get a lot of hands-on experience with the Cell processor. So you'll understand this one instance very well. So that is what we're expecting that happens at the end of these 3.5 weeks. So the project, you proposed the project. So we did something different. So it's all your ideas that we are going to do. And we selected 7 groups out of this. There are 7 projects in there. And mainly of the strength of project proposals. And I was pretty impressed with the kind of things you guys proposed. And so here are the 7 projects. So let's actually try to figure out who's who. Who's doing distributed real-time ray tracer? OK, that's that true. OK, how about the global illumination? OK. Linear algebra pack. OK, good group. Molecular dynamics. OK. Speech synthesizer. OK. Soft radio. OK. Blackgammon tutor. Okay. And there are some people who are, I think, in this class thinking that they can join a group. So at the end, there are a few groups that only have 1 member. So probably go and talk to them and see whether they're willing to work with people. I'll give you a little bit of time because I'm going to finish early. So if you just come ahead and say, OK, let's ask, who are the people who are hoping to join a group? Is there anybody who came? I got a few emails. I don't know that anybody's here. Oh, good. OK, so everybody's, this is not going to be a problem. So I think the project characteristics, I will consider they're ambitious projects, but accomplishable. OK, there's no, I was worried that people will say, I'm going to build this entire thing and it will go and take a year. But I think most of these projects that they propose, I think is doable. And another thing, it's important and relevant things. They're not doing any kind of things that I think a lot of these things, if the code is done right, I think other people might even use it. I think this kind of can start something. It's not just going to be this project. And there's a lot of opportunity to sizzle. I think some people will come up with these things that I think at the end will be so amazing. So and that's what got me excited. But get them started as soon as possible, because this is not a semester course. This is going to run so fast. There's only few all-nighters you can pull, basically, in 3 weeks. So here's a note of caution. Cell processor is very new. We heard about that today. I mean, it's a really cool thing, but it has its problems in there. It's not an easy architecture to work with. OK, there's no this nice abstraction. So it just went from this being completely abstracted out writing Java code to all the way to metal. So I mean, it's just almost a jump from going high-level language to assembly. So there's a huge, big gap in there. And that's going to create a lot of issues in there. The tool chain is very thin and brittle. So Mike pointed out all those things. He wished there was a tool, but there's nothing. And even the existing tools, I mean, we just got the SDK 2.0 working, I think, today morning. And so there might be issues in there. Most of the stars have limited experience. I mean, for example, SDK 2.0, we just got it working, so we haven't used it yet in there. So that can create problems, especially in a fast-moving course. And the projects you are doing are of your own making. Most of the classes, if we need to do undergraduate classes, we actually come up with the projects, TAs go and implement it once, we know all the gotchas, and then when you get the project, we know there's existence proof that it's doable, it works, everything, the tools work, we know at least there's one path through it. There's nothing like that here. Everybody's kind of just jumping at it head on and hoping that there's we can reach them, and we might find issues that are like very hard, and that's why we actually have very close contact with those guys at IBM. So if things happen, we'll call them, they will be available to help us. But it's not something we can say, oh yeah, I know, just go do that, or here's a way out. So there might be issues like that. So we have to be very careful of that, and you will face this kind of problems. Okay, so I mean that's more given than anything else. So be ready for that. I mean, this is not just writing some high-level code and getting away with it. And we're all in this together. So the staff, you, me, everybody. There's no. We are just doing it for the first time in some sense. And that's the fun part about it, because as he pointed out, there might be some stuff that you guys come out that will become more like folklore and the basis for the things people do. Because you might say, hey, there's a neat way of doing that. You'll be the first to do this kind of thing. So that's that time. But on the other hand, in a 3-week course, it's a large chunk to buy. If it is more for PhD research, you can say, yeah, okay, spend 3 months figuring it out. There's no time like that. So we will try to manage this process, but always you need to try to expectations of what you're trying to get done and the ability to get it done. So you have to always balance this out. If you're running into issues, get to us very fast, because we need to figure out, and we might have to actually also figure out from somewhere else, so we can escalate it up and get the information, because 3 weeks are going to go so fast. How many people are taking for grade? Okay, so people are taking it for grade. So here's what we are going to do. The first thing, what I call mini quizzes, it's just a prop so you will come into class. So the way I'm going to do that is, at the beginning of the class, I'm going to give you a piece of paper with 2 questions from the previous lecture. You can do anything you want to answer it. You can talk to people, look it up, whatever. And at the end of the class, basically we want it back. And the only requirements is you have to come individually to pick your thing up, and you have to come individually to hand it in, and you can't try somebody else's answers physically, but you can talk to each other. So this will be, we'll try to make it a little bit entertaining and a little bit thought-provoking, but nothing like you have to spend hours doing that. It will be probably 5 minutes looking that. Hopefully normally we will do a break in between, so you probably can talk to each other and come up with some answers. So this is just the fact that the people who are actually getting the grades will be coming to class, and more than anything else, I think I'll be testing. And then we have these lab projects at the beginning that will get some grade, and the final group project. And then we have final competition. So since everybody's not doing the same project, we are going to decide on performance. So how well your code ran, how much MIPS or GOBs you were able to get from that, and how raw performance in there. And then we will also look at it from a complexity point of view. So for example, as Aaron pointed out, if you do matrix multiply, you get certain performance, or if you do FFT, you get certain performance. So just absolute numbers is not what it matters, but how far you can get a hard algorithm to. Completeness. So were you able to get your project through? How much do you actually have complete solution at the end that something works? That's important. Algorithmic complexity. How much of a complex thing did you bite in? Both more of a pure algorithm point of view and also implementation complexity in there. And demo and presentation. So okay, those 2. So we are going to select a winning team. And we haven't figured out exactly what I think, but the gift, we will give everybody a gift certificate depending on, and this is what we are aiming at right now. And also, we are going to invite the winning team to spend a day at IBM TJ Watson. You get to give a presentation to a bunch of people there and probably go see what they are doing, and I think this will be a fun day. to spend. And then we haven't scheduled a day, depending on the class schedule and stuff like that. The winning team will get to go spend a day out in there. I think that will be a fun thing to do. I mean, there's a lot of cool stuff going on there, and they will get to actually interact with some researchers, see what they do, as well as present this work to them. And since this is new, everybody's excited. I think hopefully we'll come up with a team that will do things that other people will be interested and will use. So this is kind of coming from the backward because I wanted to get Mike Prawn first. So my name is Saman Namar Singh. I live in Seasale. I have had a lot of interest in, so yeah, not as much as you guys probably. I have a lot of interest in languages and compilers and computer architecture. So if you have been at this game for a long time, in early 90s, there was a huge surge in parallel performance work on parallelism. And at that time, I did the Swift parallelizing compiler in there. And then everybody says, hey, there's this Moore's law performance. Who cares about parallelism? So there was this decade of this parallelism kind of died down. I kind of hid under the radar and kind of survived through that thing. And then again, I think parallelism coming up. So we are doing some bunch of parallel work in here. So I probably have a perspective that goes somewhere old and then coming up. Probably Alan can also probably relate to that kind of. Yeah, exactly. Going through that kind of survived in that. And Roderick is sitting in there. So Roderick is right now at IBM TJ Watson, but he's probably going to live at Seasale next month. So he's going to be here more than me, in fact. And so he was actually in the lab till a few months ago. As a research scientist, and he's also interested in a lot of these kind of things, compilers, architecture, parallel architecture, and FPGA type work. And then we have two TAs, there's David and Phil. Okay, get out. Okay, so they actually have some experience probably. They are about a week ahead of you on understanding cell, not too much, but hopefully they will be able to. They are going to lead the recitations and be available to help you in there. So really use those resources as much as possible. And then we are going to have huge amount of guest lecturers, and I was pretty happy with the kind of list we got. Mike Prawn just came and gave you a lecture, and Alan is going to talk in a few weeks, and Professor Arvin, Brad Krusmall, Mike Acton that Mike Prawn talked about is going to come at then, and Bill Thies, who was one of the PhD students in Streamit group, is going to talk about the Streamit language. So the way we have kind of structured the class is, how do you go extracting parallelism? There's implicit parallelism. And sometimes the current way of everything done by hardware. So in next lecture, I will just touch upon how superscalar hardware, what it is, and what its problems are. Then implicit parallelism means you can do by compiler. So you write a C program and let the compiler deal with the parallelism. For as long as you are a programmer, you don't have to deal with that thing. And I will in lectures 11 and 12, I will talk about parallelizing compilers. So we'll cover how you can do in that way. So that means kind of abstract it out and leaving it out of the end programmer. So it's the hardware exposes it, but we put a software layer. And then the other end is explicit parallelism. That's where I think we are going to spend most of the time in this class. So the first part of explicit parallelism is a library approach. So what that means is you are using MPI type thing. So you are basically at the metal dealing with this parallelism. And I am going to do lecture 4 on concurrency. So how many people took 6170 when last year when I was teaching? Okay, so you might, I mean, I did a lecture on concurrency there, so something very similar I'm going to do in here. So to get the basics of parallelism. So in order to write parallel program, the program has to run concurrently. So a lot of issues running concurrent program is necessary to get parallel. It's not sufficient. There are a lot more other things to worry about. But let's deal with those kind of issues in that, to deal with things like synchronization, deadlocks, and issues like that. So I'm going to get that. And then Roderick is going to have a few lectures on design patterns. So if you're trying to write parallel program, how do you look at it? Different algorithms will have different ways of parallelizing. So he's going to go about and looking at these kind of parallel patterns. Okay, if you have this kind of program, here's a way to look at this. Here's another way to look at it. So kind of go through that in there. And and also go from, in concurrency, I will work with a lot more of abstract parallel model and get slowly down to all the realism needed in dealing with cell. And then we are going to have a bunch of guest lectures, mainly dealing with other ways of doing parallelism. So this is one way. So we are going to have early lecture and stream it, because you might be able to use that also as a way on cell. So a little bit of higher abstraction, we are trying to make that available on cell. So if that comes true, then you might be able to even have that as a part of your toolbox in there. The other 3 talks are about very different approaches for parallelism. So I think this will give you a big picture view. It's not you're just going through one tunneling down in there. So I think at the end of the day, you'll understand not only how to deal with cell, but kind of general way people looking at parallelism and different approaches to parallelism in there. So the lectures are organized as follows. So we are now end of the day here. Tomorrow we'll have a recitation on getting to know cell. We are trying to figure out a good room. So just check for your email to figure out exactly where we are going to have, because we are trying to figure out whether we want to find a room with machines so everybody actually get a hands-on experience then, kind of a lecture format. And then we will have the architecture, just general parallel architecture, and introduction to concurrent programming. And then Roderick is going to have meet with individual groups, trying to get the groups projects going. So at that point, kind of figure out how we are doing it, have some early ideas about it, so you can start thinking and start the process of doing that. You can start working on cell probably from tomorrow, but you will get a day to kind of get familiarized, and then here start the project. And then we will have some lectures on design patterns in here. And as we go, we'll have more hands-on experience also going on. And then we'll have a lecture on Stream It. So if you are using Stream It also for a part of the program, run program, you will be able to understand what's going on. And we'll get to some debugging tools. Hopefully you'll have to deal with these things before that, but here's something that if you're really stuck, to get a breadth of tools available in here. And then we'll talk about general on debugging and performance monitoring and performance optimizations. At this point, hopefully you have done the first cut, you have figured out what problems and start optimizing things in here. And then we will go into a little bit more depth, a little bit more breadth, things like classic parallelizing compilers that I talk about, getting implicit parallelism in here. And then we'll have a bunch of guest lectures coming in. And we'll talk about some hardware and future, because I think we are just starting this very new phase in programming that might change almost everybody. 5 years, 10 years down the line, if you go through computer science, we might have a very different flavor if what people think in parallelism takes hold. And so let's look at some future and talk about that, and it's a nice way to finish lectures. Few more days, and then we'll have group presentations in here. So each group will get, I think, about 15 minutes time to present what they have done and give a little bit of a demo. And then finally, on Friday, we'll have awards and reception. So this is what we got. And any questions?
For recitation, if we're not in a room with machines, should we bring laptops?
So okay, that's a good question. Does everybody, who doesn't have a laptop they can bring? Okay, we might be able to bring, if that is the case, we can have in any room we want and have the network, and we might have 1 or 2 additional machines for people who don't have a laptop, and that actually will work much better than everybody marching into some kind of a computer room that's not structured properly for doing a class. Okay, that actually helps a lot. Actually, that's a good point. I think that helps a lot. Okay, we'll do that way then.
How do we get access to the machine?
Okay, Roderick, you.
I have every group has a PS3 dedicated to them. I have, and every group has accounts on their dedicated PS3. I have your usernames and passwords. I will pass them out tomorrow, because I'm going to propagate the new SDK to all the PS3s to sort of test it with one and make sure everything's working. So you'll get them at the first recitation tomorrow. Unless you really want them today, then come talk to me or send me
You don't
email.
get to take home. It's all
What do
sitting.
you mean by SSH?
Yeah.
Yes.
We couldn't even put it on the machine room because they were scared somebody's going to take them home. So we actually have it in a different room, closed, nicely locked, on the network. So I have been a very popular person lately. A lot of people have tried to bribe me to get access to one of these boxes. So.
I know some people here too, and you want the SDK and some of the tools that we're using, let me know, and we can get you those.
How much does a PS3 cost?
Officially 600, but I think on officially 600, but then eBay it's like going up to about 2,500 these days. No, that's gone down. Oh, okay. Oh, nice.
Yeah.
Oh, okay, but during Christmas it was around for. I mean, yeah, there are few desperate parents who were trying to bribe me. So okay, so I guess their volume has caught up to.
No, the demand is dropped.
Okay. Okay.
All on the Wii.
Yeah.
No.
The one we have said work.
Do we ever get to see the PlayStation?
Yeah, I mean, we can bring. I mean, tomorrow we can bring one. Yeah, in there. Yeah. Because I mean, if you're putting game, it's fun. You can put a game and play that. But this is going to be Linux, so it's a little bit boring. So.
So these machines actually cannot play the games.
You can. It can. The interesting thing is that these are very because mostly these game machines are sold for less than its production value. So Microsoft and Nintendo and Sony before they made sure that nobody can run anything other than the published games that they've charged $25 per pop to recover the cost in some. Huh? No, $60 is the game. I think they're charging $25 from the game maker just for the privilege of running the game. That's how they make the money. But for Miami, when they made PS3 bootable by Linux. So in fact, it's a much cheaper. You get a Blu-ray player and a pretty this cell processor for a lot less than the production cost.
Does Linux on the PS3 run on top of the PS3 OS still?
No. It just boots up PS3. What it does is, in fact, you can't have access. Right now, you don't get access to the graphics processor properly. So you can't run OpenGL or anything. You have frame buffer access, but you don't get the full graphics access out of that.
Which distribution are you using?
Which one?
We're using Yellow Dog. So in other words, Mario and Luigi are subsidizing high-performance computing.
Yeah, exactly. You should all those shoot 'em up games is basically what subsidize. Actually, he said in one sense, you get the processor crossed down to $200 because they are selling all the things. And the other thing, actually, if you want to build a high performance like a server farm, it's probably cheaper because I think the cell blade would be a few $1,000. It should be cheaper to buy a bunch of PS3s, connect them together. But there might be issues about things like network access, file access, because I think as you point out, the board access is pretty primitive. Because for games, you don't need this high bandwidth connectivity. You just need to download it once. So there might be issues using it as for a cluster. Okay. Anything else? Okay. Good.